Hi, a quick reminder video on solutions and concentrations and titrations. Remember, concentration is the number of moles per decimeter cubed. And so the units are mole decimeters to the -3. And the equation is concentration equals moles over volume. But the moles, that's fine, the volume has to be in decimeters cubed. So we can draw a quick triangle if we wanted to. We put moles at the top with concentration and the volume on the bottom, but the volume is in decimeters cubed, remember. That's just normal decimeters cubed, not per decimeter cubed. Sorry about that. Okay, so you've got decimeters cubed, but we often don't use them. We sometimes use meters cubed, and we often use centimeters cubed. Now, a centimeter cubed is a milliliter, and the decimeter cubed is a litre. So if we go from centimeters cubed to decimeters cubed, we divide by 1,000. And if we go from meters cubed to decimeters cubed, we times by 1,000. And we can use these in the same sort of principle, from decimeters cubed to meters cubed. Right, that's quite important to know. Another thing we sometimes find is we might end up with a concentration in grams per decimeter cubed and be asked to work it out in moles per decimeter cubed. And all you need to do, if you get that, is you divide by the MR, and that's a quick conversion. Right, so this is an example of a titration. But what is a titration? Why do we do a titration? What are they for? Well, a titration is a type of a calculation whereby we use one solution to find the concentration of another solution, and that's all it is. So here's an example of a straightforward titration calculation. I say it's straightforward, why? It's because the ratio is 1 to 1. If you look at the equation, find the concentration of sodium hydroxide if 20 centimeters cubed of sodium hydroxide reacted 25 centimeters cubed of 0.1 mole per decimeter cubed HCl. So the first thing is we know most about HCl. We know its volume and we know its concentration, so we can find the moles. And the moles is moles equals concentration times by volume. And the volume must be in decimeters cubed. So we've got 0.1 is the concentration, divided by, times by the volume, which is 25 divided by 1,000, because we're going from centimeters cubed to decimeters cubed. And if you remember earlier, we said to do that, we need to divide by 1,000. So that should give us a value of 0.0025 moles of HCl. Like as with all other calculations, the next step is, or mole calculations, the next step is using the mole ratio. So we know the moles of HCl, now we can use the equation and the mole ratio to find the moles of sodium hydroxide. So we're going to use mole ratios. So we've got HCl to NaOH. We use the equation. The ratio from the equation is 1 to 1. But we've got 0.0025 moles of HCl. So therefore we must have 0.0025 moles of sodium hydroxide. Now step 3 is we're going to try and find the concentration of that sodium hydroxide. So find concentration of NaOH, and to do that we do concentration is moles over volume, but the volume has to be in decimeters cubed. Now we know the moles from the question earlier. The moles should be 0.0025, but we need to go back and check what volume of sodium hydroxide was it, and it's 20 centimeters cubed. There you go, that should be cubed. So we've got 0.0025 divided by 20 centimeters cubed, but if you it needs to be in decimeters cubed, so it's 0.02, or 20 divided by 1,000, which equals 0.025 over 0.02. We put that in the calculator and we should get a value of I think it's 0.125 moles per decimeter cubed. So that's the concentration of sodium hydroxide for the reaction to occur. 0.125 moles. We need to put the units in, moles per decimeter, cubed. Now we can make this a little bit trickier by not having a 1-to-1 ratio. So we've got an example here. Example 2, find the concentration of H2SO4 if 20 centimeters cubed react to 25 centimeters cubed or 0.1 moles per decimeter cubed sodium hydroxide. So the first thing is we know two things about sodium hydroxide, so we can find the moles of sodium hydroxide. So we've got concentration, volume and concentration. Moles equals concentration times by volume in decimeters cubed. So therefore it's going to be 0.1 times by 25 divided by 1,000. So that's 25 times 10 to the minus 3. Use some fancy indices. And that should equal 25 times 10 to the minus 4 moles. Right, next step is to use the mole ratio from the equation. And the mole ratio of sodium hydroxide, I'm going too quickly here, new mole ratio to find moles of H2SO4. So we've got sodium hydroxide to sulfuric acid is, the ratio is 2-to-1. We get that from the equation. So if we got 0.025, if we got 25 times 10 to the minus 4 moles of sodium hydroxide, we need half of that in sulfuric acid. So 25 over 2 times 10 to the minus 4. Let's tidy that up. 25 over 2 is 12.5, so 12.5. So let's just tidy that up. So that should be a ratio of 12.5 times 10 to the minus 4 moles of sulfuric acid. Right, need to check what we're doing next. So 3, we need the concentration of sulfuric acid. Find concentration of H2SO4, which equals concentration equals moles over volume in decimeters cubed. So it's 12.5 moles over volume, decimeters cubed. Let's write that down. So that's 12.5 times 10 to the minus 4 moles divided by, 20 times 10 to the minus 3. Okay. Quick maths here. We're going to work out to equal, bash this in on the calculator, it should equal 0.062 0.25 moles per decimeter cubed. Same as the previous example, but the ratio is slightly different, so we couldn't just assume a one-to-one thing. This is more what you'd expect for an AS type question or a hard GCSE one.